on LinkedIn and YouTube. So welcome to everybody joining us from there as well. Hello to India and hello to US and hello to the UK. Hi, good to see you, Matthew. Okay, so we're gonna get started, and for those of you who are maybe joining us a bit later, you can find the recording on the YouTube and also on our webinar library. So once again, welcome everybody, and thank you for joining this Hyperledger in-depth webinar with Japan Securities and Clearing Corporation, or JSCC, on Besu production launch and its next steps. My name is Tomasz, and I'm an ecosystem manager at the Hyperledger Foundation. Today, I have the opportunity to take you to some housekeeping and introduce you to our esteemed panelists who will present the content. So first, and if you have joined any of our other live webinars, you know that all are welcome in Hyperledger community, and we strive to create a safe and welcoming environment for everybody. So please read our code of conduct, which you can find on our website and on our wiki when interacting with each other or when interacting with other people in community as well. So all of the Hyperledger Foundation are run under the Linux Foundation antitrust policy as our meetings involve industry competitors. And you can find our antitrust policy also on our wiki and on our website. This session is being recorded, and you can always return to it if you missed some details and see, you can find it on YouTube as well as in our webinar library, along with the slides for your download. Now, we encourage these webinars to be quite active, and we encourage you to interact with our panelists. And the more interaction we have, the better experience for everybody. So please feel free to raise your hand, to get unmuted, and to speak up. If you would prefer to type in your questions, you can either use the Q&A box, and our panelists will either answer them live or type the answer there, or also the chat. You can use the chat button for there as well. For those of us joining on YouTube and LinkedIn Live, feel free to also use the chat there, and we will relay these questions to the panelists at the end of the webinar as well. Now, without further ado, is it my pleasure to introduce the great panelists from today. So first we have Kai Miyazato from JSCC, who is the head of IT innovation. We have Naren Krishnan, who is a senior IT architect at IBM. We also have Sakit Sethi, an application specialist for blockchain at IBM, and Samit Reddy, who is at Aurora Solutions, which is helping JSCC with its consulting services. Now, without further ado, Miyazato-san, over to you.
Thank you, Thomas.
Yeah.
Hi, everyone. So we are JSCC, and we joined the Hyperledger Foundation last October. So we are a new member. We launched the first DLT production system January last year. So today is the first opportunity for us to provide shared information. And this is our first contribution activity to the Hyperledger Foundation. So before technical session, let me explain who is JSCC and why DLT and how to use DLT. Just 5 slides as an introduction. So at first, JSCC is a Japan Security Clearing Corporation. JSCC is a part of the JPX Group, including the Tokyo Stock Exchange, Osaka Exchange, and Tokyo Commodity Exchanges. So the role of JSCC is in the middle post-trade process. This is the JSCC territory. So JSCC received the trade data from equity trade data from Tokyo Stock Exchange and the listed derivative trade data from Osaka. And also after Lehman crisis, global regulation require to concentrate the all risk into the CCP. So JCC received the OTC derivative trade or Japanese government bond cash. So JCC, we called a clearing house or central counterparty CCP. And also we categorized as a financial market infrastructure, FMI, so which should take care of the market stability to avoid the systemic risk. So in Japan, the Central Bank, Bank of Japan, and the CCP, JCC, and also the CSD, JASTEC, these three organizations are categorized as a FMI. And the last number is just for your reference, it's quite large number of the trade JCC receive every day. So the point is the 70% of this number come from outside Japan. So it means that global broker and global buy-side investors. Therefore, JCC shouldn't be a Galapagos solution. We should carefully listen to the voice from the global market, and also we should think about the more harmonization, a cross-border solution or cross-market solution. That is a background of JCC. So please move to the next slide, page 3. So we started the DLT research from 2018 and start from the data platform discussion as a market infrastructure. Because in the market, no good data platform in the middle. So that's why the many efficiency, many manual operation. That is DLT could be a good solution to have the breakthrough for that current efficiency. And since 2020, we started the more deep discussion about the asset tokenization. So today, we would like to explain about the short-term visions asset tokenization. So we launched the production January last year. But at the same time, we are doing a lot of POCs for the long-term vision. So this is more next 3 years and 5-year solution. So we touch as wide as possible, and we try as many as a business use case. That is a long-term vision. But today, we really focus on the short-term vision. So next slide is, so this is the first DLT production use case. So we use the DLT in the physical delivery process for the commodity futures final settlements. So this is not the core function. This is a small part of the business process, but this is really good area to use as a first step. So phase 1, we start to launch the rubber future physical delivery. And now we are discussing about the precious metal, gold, silver delivery. But to do this, we need to change the Japanese law. So now a change request to the government to do that in phase 2. So the phase 1 concept, we listed 5. Number 1, 2, 3 is mainly the DX, digital transformation approach. So scope is really narrow, but the obvious benefit and the operational efficiency, and also the under the COVID situation, people don't want to deliver the paper hand to hand. Therefore, it's really good to reduce the that kind of delivery risk. And number 4 and 5 is more DLT part. So we start to use the DLT solution but not this. This is just a first step, and also we are looking at the phase 2 and phase 3 and phase 4 for the future expandability, and also the thanks to the open source, we finished the 3 or 4 months implementation, and including the design and the user acceptance test, in total 5 months launch, and also the low cost due to the open source. So this is just 5 key concepts. And next page is just overview of phase 1 scope. So bottom part is what's as is solution before the January last year. So JCC is in the middle, and JCC received the warehouse receipt from sell side, from the right hand. So physical commodity delivered into the storage company issue the warehouse receipt, and the client seek to pass to the client member A, and the client member bring the paper to the JSCC. And also the other side is cash, money comes from the buyer side. So we change the only warehouse receipt part into the DLT platform. So we use by using the ERC 1155 on the Hyperledger Besu. But this is really simple use case. So all token is used within the JCC business and network in phase 1, but potentially in phase 3 or phase 4, this token could be used outside the JCC. So that it become more like a tokenized approach. But we selected a really good use case as a first step. And next slide is touch a little bit about the long-term vision. So number 1, 2, 3 are main CCP asset flow. So number 3 is a DBP settlement of the equity settlement, cash equity settlement. So CCP and the CSD in the middle, and CCP received the money from buyer, and they receive the equity from seller, and in the middle and compress, and also the provide a secure and safe settlement in the middle. That is a DBP settlement. And once in the world digital equity tokenization is used, and also digital yen is used, in that case we can transform the current situation to the purely digital settlement. But actually it takes time, because all clearing member firms agree to use the digital yen or digital equity. Therefore, I think the number 3 DBP settlement could be a last piece. And the middle part is a cash settlement. So this is for a derivative market. So CCP received the money from loser every day and send the winner. That is the cash settlement scheme. But this is also the all clearing member firm agreed to use the digital yen in this situation. So total number is plus minus 0 in the middle in CCP. But number 1, the collateral deposit is much simpler. So this collateral is used for the member default case. So CCP received the collateral from the clearing member A in case of the clearing member A default. So CCP keep a huge amount of the collateral in the CCP account. The point is CCP sets the eligibility rule, not only one product asset. We can provide some options, digital yen or digital yen or equity or US dollar or US Treasury. So clearing member firm can choose, okay, I want to use a normal yen, or I want to use a digital yen. That is possible. So that's why JCC foresee the collateral use case may be the first step as an asset tokenization solution. Therefore, long-term vision, we are doing lots of the POC related to the collateral deposit. So that is my part. So I will pass our tech team. Nani-san, could you?
Yep.
Yeah, please. Thank you. Yeah.
Thank you, Mezura-san. Thanks for setting up the business context. So I will start with the technical backup and other processing part of it, and then followed with my colleagues who will deep dive into this, the technical aspects of it. So I want to start with this technical session by going over the non-functional requirements that we had to go, and also the non-functional requirement is very vast in size. And so I want to focus on the backup and the some of the challenges we had on this. One of the requirement that we had from right from the beginning is to make sure that no data loss, zero data loss during any of the failure of the availability zone. So like, as you know, you have multiple availability zones, and any one availability zone goes off, there should be zero data loss and zero impact to the application as well. Also, the backup creation itself should be automated and seamless. The backup, as you know, it's made so that it can be used in a future situation. So if it's involves multiple manual steps, as you can imagine, it delays the effort to come up, bring it back up. So we wanted to be right from the beginning to be fully automated and seamless. Also, when we look at the backup as such, we wanted to make sure that the system that we are doing for the backup and recovery, of course, is working for 5 to 10 years down the line in terms of the the growth of the ledger size. So we didn't want to box ourselves to one type of mechanism that can be done one way and then find ourselves not good later on. Another important point, which we started out with this, is to make sure that the data that's being backed up should not be kept in some place which is itself opens it to other parties, right? It should be as secure as the blockchain, if not more secure, and then it should be accessible to not anyone outside the blockchain as well. Then with regards to the bulk processing, again, there are some instances where we had to run a batch processing of not like an end user doing it, but a batch processing that helps that pushes more data in a single time. For that, we wanted to make sure that at least up to 50 token in a single transaction can be handled. We did try for a longer one, but we kind of settled for 50 to make sure that we did all our testings on that. The logs, especially the logs for the backup itself, again, I'm now looking at the logs for the backup. We wanted to keep it for a minimum of 2 years to make sure that we have the proper auditability. And also the recovery time has to be within 2 hours, not just on the availability zone, but beyond that, right? It need not be even a disaster, but even the system failure, for example, or any of region failure, you want it to be within 2 hours. This is one of the things which we are looking at going forward as well, to make sure that we have it in a multi-region. So right now we are in a single region, which I'm going to talk about. So I want to go into the details of what we have achieved. I think the best way to do that is to explain what we have right now. Again, this is the overall architecture diagram, which I think which Sami-san will go into detail later on. So we have about 9 Besu nodes, 6 of them validators and 2 RPC. I'm going to be focusing on the backup node at the bottom, right? As you see, they are spread across 3 availability zones in Tokyo region. And if I focus bottom, if is the backup part of it, right? The backup node, we created a backup node by creating a read-only node of on the Besu by disabling the RPC endpoints, so that the aim of the backup node is to make sure that it has a read-only copy that can be backed up. So during the backup process, what we do is we stop the Besu on that particular backup node. So rest of the node is still active, but on that particular backup node, we stop the Besu, and then we back up all the data under the data directory, like tar them and compress them, and then push that into S3 backup bucket. And as you know, the S3 itself is a cross-region S3, so it's available across multiple regions as well. So once we make sure that the file has been, the backup has been pushed securely, then we bring back up the backup node. And then once the bring backup node comes onto the part of the network, then it quickly catches up and then syncs up with the data. So this, as you see, it's very critical in our design, and we made sure that the backup is. I'll go back to the challenges for now, but we looked at, by doing a systematic approach of this backup, what we also had to do is to make sure that the growth of the data, as you know, the blockchain has data in immutable ledger, so that keeps growing, right? And we had chosen the forest mode enabled in the Hyperledger Besu that allows us to do the pruning later on if you have to. So if at all, really, we are still handled for the 10x growth in data, but we have to do it later on. We can use the pruning part of it. And as I just mentioned about the read-only node, the read-only node had to be down at that time, right? Because what happens is you don't want the ledger to be updated while the backup is happening. Though we did test it and it seemed to be okay, but we didn't want it to be. We want a clean backup. So that's kind of the decision that we made. And with regards to backup, we do a daily backup, but again, that shouldn't stop. We can do a much backup every 12 hours or even more frequent, because all it does is it doesn't affect the availability of the Besu. It just brings it down, and then just the backup node, and then it takes the backup. The bulk processing, we had a whenever we pushed it with the large TPS, we had this nonce challenges. As you know, the nonce is in a blockchain Hyperledger Besu, right? It's stored in Redis, and when multiple nodes, again, when you same account, same ID, when a large number of volume is there, we have load balancer that splits across multiple availability zone, and then if it is request from the same ID at the same time is sent zone, which we don't think it really works during a real processing, but in a high volume bulk processing that could happen. So what happens is the request from the same ID, sorry, two different requests from the same ID is being sent to different one, and both handle it at the same time. If it's within the time taken by the Redis to replicate, then what happens is both of these nodes get the same number, and in which case it one of them would go through and the second one would fail because the nonce is already used up. So we try for some time, and then we clear up the transaction pool, and then the API, and then the above transaction layer we resubmit it. So we were able to automate this process as well, and then we were able to handle those error conditions. With regards to the backup, again, the retention of the backup file, we, as is mentioned before, right, we push it to S3, and then we also have a 7-day daily backup, and then we rotate after 7 days. Let me. Okay, I will hand it over to Sami-san for the next couple of slides.
Hi, thank you. So I'm going to present next one of the challenge we had to face when creating the production system, which is disaster recovery. So let me first explain why it is particularly important for us to take care of disaster recovery. So the main thing is that Japan is in a very high-risk zone. We get hit very frequently by earthquake, tsunami, and typhoons. So it's a legitimate concern for JSCC to make sure that the system will not break in case of an incident happen. On top of that, JSCC is a core financial institution in Japan, and they have a lot of responsibility toward other financial institutions. So we have to make sure that the requirement of the policy will allow like a high availability and a high resilience system. So I'm going to share some of the requirements that will impact our design. So for example, I think Naren mentioned it before, we have to make sure that in case of an incident, we have to recover the system in less than 2 hours. And we also have to make sure that all the system is hosted in Japan, and the backup on data on all the system cannot be all in the same location. We have to split the system in multiple locations in case of one location go down because of earthquake or other incidents. On top of that, we also have some blockchain-specific requirements that we had. So one of them is that we don't want to have gas fee for our customer. We also want to approve all the accounts. So because of that, we decided to use QBFT as a consensus protocol. And one of the requirements that come with QBFT is that we need two sort of validators always running at the same time. And I didn't mention earlier, but all the network will be handled by JSCC. So JSCC has to ensure that all the nodes, all the validator nodes are running correctly. So now I'm going to show the solution. Can you go to the next slide? So the solution we came up with is to create an AWS cloud with 3 availability zones and split our node in 3 zones. Here you can see there is 9 nodes. So 6 of them are validators, 2 are RPC, and 1 are backup. So if we split the 6 validator nodes in between the 3 regions, if one zone go down, we still have 4 validators, which still allow the network to continue. And then the RPC nodes, backup nodes are just there for, we just decided to split the responsibility and only have one single responsibility per node. So we have RPC nodes and backup nodes that only do that. Can you go back? Yeah. And we also have our relational database on cache database in 2 regions. So if one zone go down, let's say AZ1 go down, we still have the data in AZ2 and our caching also in AZ2. We can easily, in less than 2 hours, start up our orchestration system in that zone and redirect all our traffic into the zone 2. So this allows us to create this disaster-proof system. And I think I'm done. Maybe Sais can continue.
Thanks, Ami, for the context on the current architecture and our disaster recovery system. So now I'll be taking over the future initiatives, JSCC, what they are working on currently as part of their short-term initiatives, and also be bringing up some of the long-term initiatives JSCC would like to do in the next 3 or 5 upcoming years, or in collaboration with other organizations as part of the global outreach, like making their self open to the whole world, right, for the better usage and broader adaptability. So in the right, as you could see, this would be the ideal life cycle of any complex system, starting from a single AZ testing in a dev setup, and which would go to a multi-AZ environment in a production. In our case also, we are currently at the multi-AZ single region setup, and the complexity would rise, or you could have a system as complex as a multi-cloud, which is fault tolerant in multiple scenarios and highly resilient to the disasters, which Sami was talking a few minutes back. So in the past 1 year after going production, we had multiple learnings and challenges, along with the multiple POCs which you have done with multi-region and multi-cloud. So in the next few minutes, I would like to share our learnings and our challenges again, the challenge which we have learned in the past year for the community, so that everyone can help everyone in any way possible. Yeah. So again, why the main question would be like why multi-region, right? Because multi-region, when you're talking about multi-region, it's same, you're running resources in two regions, right? So like Sammy mentioned, Japan is one of the areas which is highly prone to natural disasters. And when recently itself in January, there was a major earthquake and it cut off uh, power and connectivity in some parts of Japan. So again, even though a multi-AZ system is fault tolerant to a certain extent of one AZ going down, if a whole region goes down, then the whole system availability and system business continuity will be completely halted. And in JSCC's core uh, requirements, uh, the system need to be brought back and should be available in any kind of any issues within the next 2 hours. So keeping that all considerations as part of the considerations, multi-region would help us in a few points. So I will be covering that one. So again, like I mentioned, the main concern and the main point of going multi-region in our perspective was the higher resilience and disaster prone system. And obviously, with respect, when you're going with multi-region, you get better performance also regarding latency if you're connecting from different parts of the world. A region, if you're connected to the closer region, obviously you get better performance and better connectivity to the system. And also, when it comes to financial institutions, the government or the whole body has strict regulation about with respect to data storage and data recovery. So to comply with the government standards also and the whole data compliance, we need to store the data in a robust way, and we need to spread this data across regions for the better usability and recovery in case of a region failure or any other issues. Yeah. So again, then it would lead to one more question, right? What is the difference between multi-region and now multi-cloud? Because multi-cloud also can do the same things. Actually, multi-cloud can do some things better also. So if you consider like future, like compliance itself as business compliance, where I want to partner with a separate organization and they want to join my network, but they have their whole system built up in a separate different cloud and different cloud provider, and they have all of their system in a new cloud. So if they now want to comply with join my network, and for their ease, they could easily connect to us, our nodes or our system running in that cloud and help them easier integration, a faster integration with our system. So multi-cloud provides you higher flexibility and advantages over multi-region. But again, as Miyazaki also mentioned that in future they would like to like incorporate with multiple other companies also. Like currently, if you see DTCC is creating their own testnet, and they have been very active on that one. So if in future JSCC want to like transfer, like Mizan's point was like, if these tokens need not be part of our own system, in future these tokens should be able to transfer to other networks, other companies, can be used by anyone kind of thing. So if in that, keeping all that in our consideration, multi-cloud would be the end product or end solution. But with multi-cloud, other challenges also arise when we are speaking about now spreading base nodes across cloud. Latency becomes a huge issue, and all these blockchain need to sync with all of the nodes in a periodic fashion, and all of the validators to be in sync always to reach the consensus, right? So that is one of the main concern, I would say. And there is obviously a secure connection needs to be established between two clouds, because you can obviously manage connection well securely in a purely AWS or GCP where you have the VPC peering and stuff. But when you're going cross cloud, that becomes the issue too. And obviously, when you're spreading across multiple cloud, you are sometimes left with some cloud native services which would hinder from the easy integration. So you need to modify your architecture to support the new services provided by new cloud. So there's up and downs in both the cases. But again, we plan to cross this bridge once we come there. And in our current explorations and current setup, we are going with the multi-region as we talk now. So we have started the multi-region exploration and design and development parallelly. So now the next slide. Yeah. So coming, so this is the high-level architecture of our current multi-region setup, because we haven't reached multi-cloud yet. So seeing this architecture, you could see we have split our blockchain. I wouldn't say split. It is more of a hot and cold approach kind of thing, where majority of our validators and the nodes regarding orchestration, everything runs in AWS in Tokyo region. And you could see there is one node running, read-only node running on Osaka. So why we are running a separate node in Osaka is because as currently we are taking only daily backup. If a whole region goes down, even though S3 data is replicated, it can be replicated in multiple regions, we would lose the whole day's worth of data. But now, since running one more standby node on Osaka, it's always in sync. So you have the latest ledger data in Osaka at all times. So you are minimizing your data loss to the least possible scenario, where the Osaka, the worst scenario, the read-only node would be backed by a block or so. It wouldn't be much back. So you are not losing any data at this moment. And why? And again, imagine the disaster struck in Tokyo and the whole region is down. So you could bring up the whole new blockchain network, same blockchain network in Osaka, very in a robust manner, because you have the latest backup in S3, and you just have blockchain just have to sync to the latest block present in the read-only standby node. So the recovery also is very efficient and very fast in this scenario. So this is again a very high-level diagram talking just on the blockchain perspective, but other services like RDS and Elasticast provide their innate multi-region capabilities, and they help solve that difficulties in a much more efficient and robust manner, because they are as service. So this is my like a short introduction of what our current system or what we are working on. That's it from my end. Thank you.
Thank you, Said. Thomas.
Naren-san, this is the end of the slide?
Yes, correct.
Yes.
Yeah.
Thank you. So just let me actually so quickly summarize that. So after 2018, we did a lot of the POCs, but after 5 years, we thought that maybe production launch would be a best POC. So that's why we launched the phase 1 as a really small, limited solution. But afterward, we are doing in parallel 3 parts. One is keep enhancing the infrastructure for the long-term vision, because we are not sure in the future interoperability, what's happening to network, how to connect. So at the moment, we touch as much as possible. We touch the possible solution as much as possible. And second one is we try to expand the business use case as wide as possible. And number 3 is a lot of the legal discussion to do the next. So today is really focusing on the infrastructure design and how to enhance at the moment. So thank you. So this is the end of the presentation.
That's great. Thank you so much. Oops, my camera is not here. Okay, thank you so much for all our panelists. And we do have some questions already in the Q&A box. And Sahit, thank you for answering some of them. I see that you already handled them. Would any of the panelists like to take any of these questions live, maybe?
Oh, yeah. Yeah, okay. So I see there are many questions on how we are handling gas. So like I mentioned in one of the answers previously, so currently since ours is a purely private network and there is no only JSCC or JSCC parties who the companies affiliated with JSCC application can access the network. So we have configured a free gas network. So currently, so we don't have to worry about, or we are not handling any gas at the moment. So it's pretty straightforward on that perspective.
Thank you.
Okay,
I will take a question from Jerry Kickinson, who is talking about encrypting ledger data in storage. So again, like I mentioned, this is very important. You don't want to take the backup and put it out there in the open for others to do that. So one good thing is the S3 itself has a built-in encryption. So that's one layer of encryption that we have. And we also restrict the S3 bucket access as well. So we kind of use the native AWS features for privacy. We can go to one level extra by privating, but the point is that since the ledger is also signed by some of these private keys, so even if someone snoops in on the data, that's not going to be very much useful for someone. So we have multiple layers. Right? One is at the AWS level encryption, and then the access control of the buckets, and then on top of it, it's actually the raw ledger data, which cannot be done anything without the actual keys. So.
Yeah. So I would like to actually take up a question on multi-cloud because I see one question on multi-cloud. So we had done in past few months, we had done a successful POC on multi-cloud. So so what I would say the main challenge which we faced in multi-cloud during the multi-cloud testing was like establishing a secure connection between the base nodes, because we don't want any malicious user trying to submit transaction directly to our base node with coming out without going through our application stack, right? So if you're like, that's one of the main challenges. So because now since we are talking between clouds, the innate natures of the cloud which provide through VPCs or transit gateway are not easily integratable. Now you have to integrate GCP with AWS services. So it can be challenging at first, but once you develop that secure connection between the Besu nodes, then it's pretty much done by Besu itself, because Besu has the capability to connect to its own blockchain nodes, and they would sync up by itself. So it's all about establishing that secure connection between the Besu nodes.
Thank you. Thank you, sir. I just want to answer. I know Arindam has a thing about Hyperledger. Thanks for the link, sharing the link. I think that kind of explains what the free gas versus other gas. And the last one, the anonymous attendee, where we see the on-chain privacy, that's very important because in this case, privacy is paramount, right? You cannot compromise with that, especially in this financial sector. So we do have a protected network. So we are not there out there. The final network where you seen, I don't expect it to be too much fully public network like the Ethereum and so on, but it will be some sort of a protected network. That's number one. Number two is within that, we make sure that it's available, whatever the data is available within those participants. And then also we have certain critical data is not stored on the as part of that ledger as well. So right now we have, that's kind of reason why we have it in a protected private network. But definitely that will be something that we will closely monitor as we go along as we onboard more participants and make it more open.
Great, thank you, Naren.
I'm sorry for there's some question about transactions, how much transaction we have and performance. So maybe just to explain a bit more, the way it works right now for business use case is that most of transactions happen at some period at the end of the month or something like that, where like they have to resolve all those contracts. So they will do all transactions at that time. And usually it can go up to, we design it so it go up to a few thousands in like some days. So we don't have a lot of transactions per second. We don't have that many users yet. So there's not really any performance problem. And usually when we do bulk transactions, since we're using the ERC 1155, this allows us to make multiple transactions, like send multiple tokens in one transaction.
Yep, thank you.
Right.
And just to add to that, we have a 10 seconds block time. Again, we have tried with multiple times, but that's something fits in with our requirement right now. Okay, we just now answered that, right? So, okay.
Yeah.
Yes.
So
Thank you very
regarding,
much.
yeah. So I have seen a question on how does the performance look with the high volume and traffic, right? So we have been still have challenges with managing high TPS because when you're talking a very large number of transactions entering the blockchain, right? Not even the blockchain, the orchestration layer, the nonce handling the nonce becomes very critical. So because since to resolve the nonce issue, we have tapered the transaction a bit for a lesser performance and more robust solution for risk-prone solution. But we are looking into a long-term solution which would resolve ITPS issue and like basically you mentioned, right? For a higher traffic and larger transaction input. Yeah.
Thank you.
Thank you.
Thank you. It was great. I don't think we have any open questions right now. And I see that I don't have any questions on YouTube and LinkedIn right now. Would anybody else like to ask a question? We can get you unmuted and you can ask our panelists. Nothing for now? Okay. I wanted to ask you, what would be a good way to get in touch with you for our viewers that may be watching this later on or YouTube, on LinkedIn as a recording? What would be a good way to get in touch with you?
Greg or Mizura-san?
Oh, thank you, Alfonso, for joining.
Yeah.
No.
Sorry, Thomas, could you please repeat again?
Sure. Of course. I was just wondering what would be a good way to reach you if some of the viewers have questions for you, maybe about Besu or about organization. Is there a good way to reach you?
Yeah, I'm not sure how to connect. So
okay.
Yeah, sorry, this is our first time the webinar. So after webinar, please advise us the best way.
Sure, of course. We can add some of the contacts also on the presentation, which we will have on our webinar library, and then people can reach you there as well. But we did have one question in the meantime, if you don't mind taking it, that one as well. Nathaniel was asking, does it have a multi-channel communication?
Said, do you want to answer that? You're on mute.
Yes, sorry. Currently, since we are running it in a single region, and there is JSCC is main like party or the controlling party in most of the scenarios. So we currently don't have a multi-channel setup, But in a future where we are spread across multiple cloud and we are working with multiple clients and their own compliance and their own nodes, then we could set a multi-channel specific to that user based upon the requirement also. Current requirement doesn't, as per our current, we don't actually need a multi-channel, so we haven't configured one yet.
Great, thank you. Okay. So if we don't have other questions right now, then I think we can wrap it up. If some of you have questions later on that might not get answered this time, please feel free to reach out to us at Hyperledger or at the JSCC. We will share some contacts later on as well. So first of all, thank you so much to our great panelists. You managed to cover a lot of information. I enjoy listening to the presentation. And thank you very much to our audience as well. Thank you for joining us, and thank you for your great questions as well. As mentioned, the recording will be later available on our webinar library as well as on our YouTube channel as well. I would also like to invite you to visit our events page to see all of the upcoming events. We had a webinar with Cripsy next week, and we also announce all of the live sort of events where we'll be present there as well. I would also like to invite you to visit our meetup page to learn about the upcoming meetups with the Hyperledger Foundation. There are meetups, workshops, and the events from the regional chapters announced here as well. We also produce a lot of content that is our community. So we issued an updated CBDC book. Our supply chain and trade finance SIG has, at the end of last year, published a supply chain and trade finance book. And you can find all of that on the research page as well. And we will be producing more of that content, so make sure to visit us there as well. Here is also the link to our Discord. You can use the QR code or you can follow this link. And here is a lot of live interactions with our Hyperledger project. So we were covering, or our panelists were covering the Hyperledger Besu today. So there's a dedicated channel for Besu, but also Fabric, Firefly, and so on. So you're welcome to join the Discord and ask the people questions there. And for those of us considering the corporate membership, you're also welcome to contact us at membership@hyperledger.org. So this concludes our presentations for today. Thank you, everybody, for watching. And thank you again to our great panelists for all the valuable information you provided. And for those of us watching the recording later, please remember to also follow us on YouTube and follow the organizations from our panelists as well. Thank you so much, and hope to see you again soon.
Thank you all. Good luck. Good day.
Thank you.
Thank you all. Good day.
Thank you.